Welcome back, dear students. This is Ramana sir, Physics. How are you all? We are discussing the LAQs, IP LAQs for TS and AP. Most important LAQs we are discussing. So in that last class, we discussed from waves chapter, formation of stationary waves in stretched string. The continuation, the open pipe, closed pipe. Open pipe also they can ask as LAQ, and closed pipe also they can ask individually for LAQ. So today our topic is what? Open pipe. Here last class we discussed stretched string. So if anybody missed, I given in description, so you can check that answer. Most important, along with numericals also I explained in that class. In this class I am going to explain the open pipe and closed pipe, okay, and numericals also. Along with numericals also I'll discuss in this video. Here you can observe open pipe means what is open pipe. So the last question, explain the formation of stationary waves in an air column enclosed in open pipe, and hence derive the equation for the harmonics produced in open pipe. The last, what are harmonics and what are overtones? Harmonic means what? The integral multiple of fundamental frequencies are called harmonics. Harmonic means the integral multiple of fundamental frequencies are called what? Harmonics. And overtones, the higher than the fundamental frequencies, higher than the harmonics, are called overtones. Here open pipe means a pipe which is open at both the ends. A cylindrical pipe which is open at both the ends. That pipe is called what? Open pipe. Here whenever a sound wave is sending through one open end, what happens? It travels through the pipe. The sound wave travels through the pipe. From other end, it reflected due to pressure difference. Here, what happens that time? Two transfer waves are superimposed in opposite direction. That is, two transfer waves are having same frequencies, but they are superimposing opposite direction. That meaning is what? Stationary wave is forming. The stationary waves are formed. Here, the different modes of the different modes of frequencies in open pipe now we'll discuss. This first one is fundamental frequency or first harmonic. First one, here you can observe the always antinodes are formed open end. Okay, open end, always antinodes are formed. Wherever amplitude is 0, their nodes are formed. If the whenever sound wave is sending, the first possible wave in open pipe is the two half loops we can get. Here the one is, okay, so you can observe the sound wave, first sound wave is moving. So what happened that time? So it gets reflected from other end. Why? Because due to pressure difference. So what happened that time? It gets, due to pressure difference, what happened? It gets reflected. Okay, here at open side always antinodes are formed. Open side antinodes are formed, and closed side, closed means wherever displacement is minimum, their node is formed. Here we can observe. So we know that in the last class we discussed when complete segment is there, node to node distance, we taken lambda by 2. Here only half loop is there, half segment is there. So then how much we can take here? Total, how much we can take? L equal to, what happened this time? Half segment is there. Full segment means lambda by 2 will take, but here only half of the segment is there, that is lambda by 4. Here also another half is there. Why? Because antinode to node distance is lambda by 4. Here if node to node, any two successive node to node or antinode to antinode, lambda by 2. But antinode to node is how much? Lambda by 4. Here also node to antinode, that also what? Lambda by 4. Total length is how much? L equal to lambda by 4 plus lambda by 4. Lambda by 4 plus lambda by 4. So that equal to 2 lambda by 4. 2 1 ja 2 2 ja, that equal to how much? Lambda by 2. Lambda by 2. L equal to lambda by 2. Length of the pipe L equal to lambda by 2. Therefore, lambda equal to what? 12. Lambda equal to what? 12. So this value will substitute in equations where we'll see from the velocity of sound v equal to n lambda formula. V equal to n lambda formula. N equal to what? V by lambda. N equal to v by lambda. N equal to v by the velocity of sound v value. I am keeping like that only as it is. In string time we substituted transverse wave velocity under root of t by mu, but here no need to substitute. V value keep as it is by lambda. Lambda is how much? 2L. This is say n1. This frequency is called fundamental frequency or first harmonic in open pipe. This frequency is called fundamental frequency or first harmonic. This frequency is called fundamental frequency or first harmonic. Next we will see second harmonic or first overtone. In second harmonic or first overtone, here the waves form one single segment, one complete loop will form, and two half loops will form. Two ends, two half loops will form. So we know that in open pipe always antinodes are formed at open end. Here three antinodes are formed and two nodes are formed. Here open side antinode, here also open side antinode, here amplitude is maximum, here also one more antinode. Here wherever amplitudes are minimum, node will form. So we know that half of the segment, so the length is how much? Lambda by 4. Complete segment is there, complete loop is there. What is the length? Lambda by 2. Here half segment is there, how much? Lambda by 4. Lambda by 4. Here complete segment is there, lambda by 2. Here another half is there, lambda by 4. Total length of the pipe L equal to lambda by 4 plus lambda by 2 plus lambda by 4. That equal to the 4 is the LCM, lambda plus 2 lambda plus again lambda. Lambda plus 2 lambda plus lambda. L equal to 4 lambda by 4. 4 gets cancelled. Therefore, L equal to how much? Lambda. L equal to lambda we got. Now, here from V equal to N lambda, same formula. N equal to what? V by lambda. Here N equal to V by, substitute the lambda value L. Here I am multiplying and dividing with 2. What happens that time? N equal to 2 into V by 2L. V by 2L means what? The previous case we observed, that is fundamental frequency in open pipe. That is why N2 equal to, we can write 2N1. Why? Because N1 is what? Fundamental frequency or first harmonic in open pipe. Therefore, this frequency is called second harmonic or first overtone. Second harmonic or first overtone. So like this, third harmonic or second overtone also will derive. Last case, third harmonic or second overtones. In these two full segments will form and two half segments, two ends, two half segments will form. Whenever sound wave is sending through in open pipe, what happened? Two full segments and two half segments will form. Here open end always antinodes are formed, and wherever amplitudes are maximum there antinodes are formed, and wherever amplitudes are minimum there nodes are formed. Totally in this third harmonic or second overtone, 4 antinodes and 3 nodes are formed. Here the first half segment length is how much? Lambda by 4. Full segment lambda by 2, again lambda by 2, and other end, that is lambda by 4. Here total length L equal to lambda by 4 plus lambda by 2 plus lambda by 2 plus lambda by 4. Total length here 4 is the LCM. 4 is the LCM. Lambda plus 2 lambda plus 2 lambda plus lambda. Total how much? 2 lambda plus 2 lambda, 4 lambda plus 5 lambda plus 1 lambda, 6 lambda. Total 6 lambda by 4. Here 2 2 ja, 2 3 ja. Therefore, lambda equal to 2 into L, 2L divided by 3. Therefore, lambda equal to 2L divided by 3 we got. Same from V equal to N lambda formula. V equal to velocity of sound. V equal to N lambda. N equal to what? V by lambda. Substitute the values. V value how much V only we are keeping. Lambda value how much we got? 2L by 3 we got. This 3 is in denominator, again in denominator. We can shift to numerator. Therefore, N is equal to 3 into V by 2L. V by 2L is what? Fundamental frequency in open pipe. Therefore, N3 equal to 3N1. N3 equal to what? 3N1. This frequency is called third harmonic or second overtone. The ratio of harmonics N1 is to, therefore finally N1 is to, N2 is to, N3 equal to how much we got? 1 is to 2 is to 3. N1 is to, N2 is to, N3 how much we got? 1 is to 2 is to 3. This is a complete open pipe answer. Along with this answer, attachment problem also they can ask. So we'll discuss after completing the closure pipe answer. We'll discuss the problems. Here also same question, but instead of open pipe, closure pipe they'll ask. Explain the formation of stationary wave in air column enclosed in closure pipe. Okay, harmonics and derive the possible harmonics in closure pipe. They'll ask the question. Here closure pipe means one end is closed and another end is open. That pipe is called, that cylindrical pipe is called what? Closure pipe. Whenever a sound wave is sent through this closure pipe, what happened? From open end we sent. What happened that time? So it gets reflected from other end. Here we can observe in the diagram. So here closure pipe is there. Whenever sound wave is sending, what happened that time? It gets reflected from the other end. So like here, two transfer waves are superimposing, having same amplitudes, same frequencies, but they superimpose in opposite direction. Hence, stationary waves will form. Here we know that open side always antinode will form and closed side node will form. Here in fundamental frequency or first harmonic, the minimum possible, the nodes are what? One node and one antinode will form. Minimum one node and one antinode. In these harmonics and overtones, same number of nodes and antinodes will form in closure pipe. Here we know that if complete segment is there, that is the length of the pipe is how much? Lambda by 2. Here only half segment is there, that meaning antinode to node distance is how much? Lambda by 4. Only half segment distance is how much? Lambda by 4. Therefore L equal to lambda by 4. Lambda equal to what? 4L. Lambda equal to 4L. Here same from formula, V equal to N lambda formula. N equal to what? V by lambda. N equal to V by lambda value how much we got? 4L. Therefore this frequency is called fundamental frequency or first harmonic in closed pipe. N1 equal to how much we got? V by 4L. In open pipe time we got fundamental frequency N1 equal to V by 2L. Here observe here variation V by 4L. The next case, in third harmonic or first overtone, only odd number of modes only, odd number of harmonics only will form in this closure pipe. You can observe here third harmonic or first overtone. In this, one complete segment will form and another one half segment also will form. Here open end always antinodes are formed, closed end nodes are formed. Here another amplitude is maximum, that is antinode. Here amplitude is minimum node. Here half segment distance, we know that what is the distance? Lambda by 4. Here full segment is there. What is the distance? Lambda by 2. Total length of the pipe L equal to lambda by 4 plus lambda by 2. So that equal to 4 is the LCM, lambda plus 2 lambda. Lambda plus 2 lambda. Total how much? 3 lambda. L equal to 3 lambda by 4. Therefore, lambda equal to what? 4L by 3. Lambda equal to 4 into L, 4L divided by 3. Here from V equal to N lambda formula, N equal to V by lambda. Substitute N equal to V by lambda value, how much we got? 4L by 3. This 3 is sent to numerator, N equal to 3 into V by 4L. Therefore, this frequency N3 equal to how much? 3N1. Why N1 here? N1 is fundamental frequency in closed pipe. So that is why V by 4L. That is why we take N. Therefore, this frequency is called harmonic or first overtone. And the last case is their fifth harmonic or second overtone. The last case we can observe fifth harmonic or second overtone. So in this, the sound wave, whenever we send sound wave through the closed pipe, what happened? Two full segments and one half segment will form. Here antinodes are formed at open end, closed side nodes are formed, and wherever amplitudes are maximum, antinodes will form. Wherever amplitudes are minimum, nodes will form. Half segment purpose length, we know that lambda by 4, and full segments lambda by 2 and lambda by 2. Total length L equal to lambda by 4 plus lambda by 2 plus lambda by 2. That equal to, the 4 is the LCM, lambda plus 2 lambda plus 2 lambda. Lambda plus 2 lambda plus 2 lambda. Total how much? L equal to 5 lambda by 4. L equal to how much? 5 lambda by 4. Therefore, lambda equal to how much? 4L divided by 5. Lambda value how much we got? 4L by 5. Here from V equal to N lambda, N equal to what? V by lambda. Lambda value is how much? 4L by 5. This 5 sent to numerator, what happens? N equal to 5 into V by 4L. Therefore, N5 is equal to 5 into V by 4L is what? Fundamental frequency in closed pipe, that is N1. N5 equal to how much? 5N1. Therefore, this frequency is called fifth harmonic or second overtone. Fifth harmonic or second overtone. Therefore, the ratio of harmonics in closed pipe, how much? N1 is to N3 is to N5 is equal to 1 is to 3 is to 5. This is the closed pipe. So attachment problems, open pipe and closed pipe also we'll discuss. You can take the question. A closed organ pipe 70 centimeters long is sounded. If the velocity of sound is 331 meters per second, what is the fundamental frequency of vibration of the air column? In this numerical, if we observe, so they are clearly mentioning closed pipe. Clearly mentioning what? Closed pipe. For closed pipe, length is given how much? 70 centimeters. We have to convert to meters. In SI units, we have to convert 70 into 10 to the power of 10 minus 2. 10 power of minus 2 meters. Centimeter to meter is how much? 10 to the power of minus 2 meter. And velocity of sound is given 331 meters per second. And the fundamental frequency in closed pipe, how much they are asking. We know that fundamental frequency formula in closed pipe. Fundamental frequency in closed pipe, we know that formula N1 equal to V by 4L. Fundamental frequency formula in closed pipe, how much? N1 equal to V by 4L. V is how much? 331 is given by 4 into length 70 into 10 to the power of minus 2. Here 1 0 purpose 1 minus gets cancel. What happened? 331 divided by 4 into R 4 7 ja, that I am doing 28, and 1 minus cancel for 0 purpose. One more minus 1 is there, 10 power of minus 1 is there. If you send to numerator, what happened? It will come 0. 3310 divided by 21. You solve this one by division method. 3310 divided by 28. So 28 1 ja 28. Okay, 13 minus 8 5 0 1. Again 1 ja 28, 1 ja 28. 11 minus 8, how much? Yeah, 3. 4 minus 2 2. Here what happened? Here this 0 I am taking, final 0 230. Approximately 8 ja checking, 8 8 ja 64, 6 8 2 ja 16 plus 6, how much? 22. So 224, 28 8 ja. Now 10 minus 4 6 0 0. Here decimal and 0 you can take. So 28 2 ja approximately 56, and of this one how much we got? 118.2. Therefore frequency units are what? Hertz. 118.2 frequency units are what? Hertz is the answer. So this is the answer for this problem. Open pipe or closed pipe, so they can ask this type of questions. The remaining next I'll discuss the beats class. I'll give in description that beats also. Okay, next class beats topic and Doppler effect, Doppler shift. Another 3 answers are there in this lesson. The first 3 topics are most important, like so nearly 75% or 80% most important first 3. Another 3 are 25 to 20% important. Another 3 beats, Doppler effect, Doppler shift. Okay, so if you understand this topic, please subscribe the channel. Thanks for watching.